Gadget UK here again, back for part 3 of the super corroded Amiga 4000 board. In the first 2 parts we did quite a lot of work to this board, pretty much removing everything from around the real-time clock area where the battery sits, all around that vicinity really, the SIM slots. And in part 2 we started to reinstall those things. We did get the board initially up and running, but there's still quite a lot of finishing off, cleaning up the board, getting the real-time clock stuff working, testing everything out. We did end part 2 with the Zorro slot problem. So picking up here, I'm just testing the fix we did to the Zorro slot in part 2. Yeah, so I've come to the conclusion that that was wrong from manufacturer, actually. And I think that maybe someone swapped the resistor arrays to try and resolve the problem with that slot. Anyway, you can see I've loaded a demo there. The sound is not connected at the moment, we'll just connect those cables up. Yeah, this uses a lot of RAM, so it's using that Zorro 3 RAM actually, because I haven't got enough RAM for this demo in terms of the SIMs. Yeah, so it's not particularly fast on the stock CPU here, and it may be a bit slower because it may be using that Zorro 3 RAM. And Zorro 3 RAM is slightly slower than the SIMs, you know, that go via Ramsey. Nevertheless, it's working. So very pleased. Still a lot to do though. We've got to do all the real-time clock stuff, and you know, just a complete clean really, because the board is really dirty. Let's switch that off. So yeah, I'll just remove the Zorro stuff now, I think, remove the SIMs and things, and then just go back to working on the bare board and finish cleaning up, I think, and then just maybe start to reinstall some of the things around here. Right, so still very dirty. I'm not sure you can see from that distance, but I've just used a coil wire to fix 2 traces here, the 2 wires that go underneath the real-time clock chip. So final thing I'm going to do now before I call it for today, because I'm pretty tired and it's like 10:30 at night, just get a wee bit of UV solder mask onto each of those little fix wires. And then tomorrow I'll pick up by fitting the real-time clock chip socket. We'll get the resistor array on. There's a couple of traces to patch for the resistor array. We need the crystal, the capacitor, the pin header thing here, and we'll finish off by doing the battery mod. You know, to put a CR2032 holder on it. Yeah, as I keep saying, you need to clean up before you stick this stuff on, because the IPA will dissolve it. So, you know, it doesn't look that clean around here, it's just dust and hair and stuff, so I'll vacuum as a final step. But I am nearly there now. Right, so the up direction problem on this joystick port, it's one of these really simple things. I shouldn't have put the ports on really until I tested every single trace around there, and I thought they were all good. I made a judgment call and it was wrong. The trace here, I don't know, you can see I've exposed it a little bit, from the via, it's the first one that comes down here, yeah? From there to here we have a join, and then it goes right on the inside of this port here. This is where it's corroded through, you can't see it. And it looked alright from the top side. Yeah, and obviously it's the bottom trace here, there's no join from here to there. So what I'm going to do is use a piece of coil wire, just get some flux on there, a piece of coil wire, solder it on at that point there, route it down here to about here, and then solder it on there, and put a tiny little bit of the solder mask paint over there to secure that. That's what it is. It's not getting from the port to the first point on the resistor, the top point of this resistor here, which then in turn goes to the shift register, one of the pins I think somewhere up here. So yeah, it's the direction is not getting there, and logic probing that, I've shown this technique before, I tested and it goes high impedance, and when you press it up it goes low. Yeah, so looking at the board layout here on Amiga PCB Explorer, there'll be a link down below. The first via, well actually it's the second one, that via goes all the way down. You can see it go down, 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 all the way underneath that port there, past the corroded area, right down past the jumpers and things, and then goes to that first resistor, and then from resistor goes to the shift register. And you can see that resistor there, the other side of that resistor picks up 5 volts, so that's a pull-up, it's a 4K7 pull-up. And that means that connection for the joystick is going to have 5 volts provided via that pull-up, yeah, going to the pin further up. And because the trace was cut there underneath the port, we didn't have that connection to the 5 volts. Yeah, low, nothing, low, nothing. Because the pull-up's missing, and that's what I was, I sort of figured it's, that's an easy way to test something like that. If you just see a low and it doesn't go high, it just goes high impedance, you're missing the pull-up. So yeah, it kind of just assists with that sort of problem, really. You can see I've encapsulated that wire there with some UV solder mask. So yeah, it looks a bit of a bodge, doesn't it? This is the thing, I'm not even sure the UV solder mask is any better than nail polish, to be honest. You get the kind of better, you know, it goes a bit more solid maybe, but it does take quite a while to set, and then in places it goes a bit blobby even though it's set hard. I certainly work with heat. If you go too high, you know, with the temperature or the airflow, you can get like deflections and things in the surface of it as it dries. So anyway, I've got a new socket here. Well, I say new socket, it's one I reclaimed actually from one of those C64s. I think someone put a turn pin somewhere on it. It may have been C64 C-board, so I think that's going to be the right profile for there, that's right. And then I've got two of these. I mean, I've got some of the wider stuff that I could cut down, but these have got, you know, manufacturer cut down edges, so I'm just going to stick those two together in there. And I've got a brand new watch crystal here, 32.768 kilohertz. So I'm going to mount those things next, I think. I also need to fix two tracers on the resistor array here. They're always the common two that always go here, and the wire that goes here to the pin right next to that. Those are the things that always fail on these, so I'm going to do those things next, I think. Soldering the RTC socket on now. I've just blocked a couple more wires underneath that real-time clock, so everything underneath it is dealt with, really. There should be no risk of problems with connections around that chip, that's for sure, because everything's tinned on both sides and all the wires there blocked, tested, working. Now when you've got lots of exposed traces like I have here, it can make it a wee bit difficult because you've got to make sure you don't smear solder, you know, across from a pin to a trace or between traces, etc. Just make sure that's nice and flat, and it is. If you want to get super clean job on something like this, just consider a sort of hybrid cleaning technique where, you know, you get the IPA on the solder point down where you've got crusty flux that you can't get to at all, or it's just not removing even after a few brushes. Just use a sharp tool like this. Just be careful, you don't want to scratch the PCB, but just circle the pins where the flux is, and you'll be amazed you can get every last little bit off. That last little bit of crusty flux that's holding on, it will come off, and it can just look absolutely amazing if you go to that extent. And then of course, you know, maybe toothbrush it just to get the final little bits off. But what I'm trying to avoid doing here, you see, is toothbrushing at this stage, because we've got lots of holes where IPA can leak through and affect the solder mask paint. Yeah, this is the complication. And you may think it's not a problem, but trust me, that solder mask paint will start to dissolve and it starts to run over everything, and before you know it, you've created a huge mess. So a 2-pin crystal like this, there's no correct orientation or anything, you know, you don't need to worry about polarity. Just need to bend the legs over and get it through the holes here, like that. I'm just going to bend them a bit further actually, because you can see it's shoved right up this way. They're almost like straight down on the original. Yeah, so one of the mistakes I made, I think, when I've looked at these before, there's a mounting point there. You can just about see that. So if you get the crystal at just the right angle, you can heat that, or you could heat with hot air and you know, just solder its can onto that point. I'm just pulling the leads through here, just try and get it a wee bit flatter. That's it. Flip that over and solder those points. Right, we are so near completion now. So socket, clock crystal fitted and secured down, and we've got a nice new set of pin headers there. So the only things we need now: battery, the 174, the resistor array, and the trim cap. I still need to clean around this with a toothbrush, because obviously I reflowed this side and this side. I think the way I'm going to have to do that is maybe, I don't know, tape something over here just so that this side doesn't get flooded, because I don't want any of this UV solder mask to get affected by that. And you know, I can just confine the IPA to that area there, maybe tilt the board the other way. But the next thing I'll do is deal with this. So you can see it looks black, it's greeny in there, but you can easily flush these out. Just soak in vinegar for maybe 10 minutes, and then flush, use a toothbrush, some IPA, get a bit of deoxit in there, some toothbrush again, and yeah, a bit of hot air, maybe some more IPA, and it'll be good as new. So whilst that trim cap is soaking in vinegar, I thought I'd just clean up some of these bits that need to obviously go back on. So you can see in the light there, look, you can see the greeniness and stuff on that. It's just like brass or something, this, I don't know, like copper coated, or I honestly do not know what that is. But we use some vinegar initially just to deal with some of that greeniness. I mean, this is the worst one of these I've seen, because this doesn't usually go like this. This is usually inert, well, I don't know about inert, but the kind of metal that this is doesn't usually get all this greeniness on it. I mean, it hasn't corroded, it's just a bit dirty, I think. I don't need to use the wire brush or anything on that. I'm just going to get some WD-40 next and just wipe over that with, hang on, I can. It's going to snag a bit, isn't it? A wee bit of WD-40. May just spot clean here with the wire brush or something, because that point there is just a wee bit greeny. Yeah, I think it's kind of copper coated, that, because copper goes green, doesn't it? I think when it's corroded. Alright, that'll do, that's not too bad. Right, so yeah, a wee bit of rust there. Do you know what? I think I'm going to deal with that. Just going to go over that with the fiberglass pencil as well, just on the edge here. That one's alright, actually. But this one isn't. Well, you can see it's just got a wee bit rusted there. Again, a tiny bit of WD-40 here, you can see. There we go, it's cleaned that up nicely. It's a little bit ready there. The inside of that port there, though, is okay. Yeah, I'm not going to worry about that too much. It's got a coating WD-40 on it. Yeah, and just checking the pins on these ports, they look really goldy. Perhaps a little bit greeniness there, I don't know. But yeah, they're looking okay. These, I've cleaned around these with a fiberglass pen. Bear in mind, those are the original ports. Gadget from the future here, I thought this bit was worth adding in. A good friend of mine on Discord, Robert Elliott, also known as Smiley Bob, he's been restoring his 4000 board, and similar problems, similar types of issues and things. These caps here, obviously they do leak. They leaked on mine. I did clean up around there. You can see it looks pretty blooming clean. But this one in particular, and maybe that one, can leak underneath this port here. Yeah, and in his case that happened, and I'll show you some pictures here where he was trying to remove those ports. The amount of heat those connections can sink, certainly the anchor points, it's incredible, and you need a really power capable soldering iron to heat and heat those up, and then use a desolder station maybe at the same time as a soldering iron, or just use your solder pump with a good iron. But it can still be very difficult to remove the solder. And he tried all sorts of things to get those ports to free from the board, and he couldn't do it. So I suggested a number of different things, including using good flux, using a desolder braid. Take your time, add additional heat, and crank your iron up by another 20 to 50 degrees C. So, we're talking in the range of going from around 400 on one of these boards, typically, up to 420 or 450, maybe even 475. If that still doesn't work, and it didn't for him, the next suggestion really would be to use a low melting point solder. I think he managed to pick some of that stuff up pretty cheap, but it is fairly expensive, £20 or more for a small amount of it. But then you apply that, you can see he did it here, you apply with some flux around all the connections you want to free up, and then heat with hot air. Again, you might need slightly high temperature, but as you heat around that area for a minute or two, it should all start to get molten, and then the port should come off. And he did manage to do that, and he's done a really good job. You can see the after shot here where he was just starting to clean up, and no damage. So great job, Rob. So do consider a hybrid removal where you use additional heat, use your iron and hot air, and low melting point solder. So without further ado, let's get this thing back on. Whether it's going to be aligned properly here. Oh, actually it is. I think there's no issue there. So let me find the nuts. Stick one in up here first of all. Is that going in? No, it's not. Why is it not going in? Yeah, now it is. I'm not going to tighten that yet until we've done one over here or two, maybe. And again, I'm not going to over tighten these. I just, there we go, almost like finger tight. Fantastic. It's gone together quite nicely, that. Often if you've used replacement ports here, this can be pushed right out. Not a problem. So if you do replace these ports, you've got to bend, I've showed that in previous videos, you've got to bend the sensor conductor, you know, the one that comes down its own. So it sort of goes up in at an angle and then up like that in order to recess it back a little bit. Otherwise they'll be stuck right out here and you won't be able to get it inside a case. Right, the next thing to do is clean this and stick this back over the mouse ports. It's not too bad, that, is it? Yeah, so with this I'm just going to go straight in with the fiberglass brush. Don't mistake the darky greeny bits like this as corrosion. It's not, it's just where the zinc plating has gone a bit weird. Yeah, I stepped up to the wire brush and this works a lot better actually. That fiberglass brush, I've got two soft bristles in it. You're never going to get it even looking. It's what will happen though is the orangeness should go. You can see that, you know, it's still a bit dark here, a bit black. So there's a bit of pitting or something there. You could just go over that a few more times, but as long as you get rid of the orange parts. There we go. Anyway, you can see what I'm going for really just on one side there. That's not too bad now, but the other side is furry still. Right, so the trim cap has finished soaking and I cleaned it out. You can't see very well from there, but it's gold inside already. And all of the green and crustiness come off the contacts. So I'm just going to flush it out with some contact cleaner actually. And yeah, we'll give it a try. The other thing that obviously helps with something like this is actually get a screwdriver and twist it. Yeah, get onto the surface of it and actually rotate it. That is well and truly seized up, so I might need to replace it. It's measuring decent, you know, you can go between, I don't know, 6 picofarad and 18, 19-ish. So I think that's what it is. I think it's like 6 to 20 picofarad. So just a bit further, let's see what that comes up with. Yeah, look. So it's got the full range pretty much. So yeah, I'm just going to stick that back on. Yeah, there's just a little bit of whiteness there for my liking, which I want to just remove. It's like a white silhouette. There we go, it's coming straight off, look. But the fun and games is where you've replaced the ports, you know, the hex nuts hold the metal on. So it's like a balancing act to try and get it to hold everything in place, you know, as you actually screw the nuts on. That's not too bad. You'll see what I mean here as we undo the hex nuts. The metal part of the D shape here will fall off. So we'll just leave that one almost on. Is that going to fall off? Oh, it hasn't done. That's a miracle. Those usually just fall straight off like this one's do. So we'll undo that. Get the nut out of the way. And try and get this over there like that. Yeah, one of these things goes under, one goes over, like that. Yeah, I'm not sure what's going on with this side here, but it's not going right up. What is going on? Oh, that's it. Yeah, this was not flat. It was like at an angle sticking out. But there we go. So everything's perfectly lined up there. The ports are perfect with the PCB. If you don't get that just right, then obviously these things will, you know, the nuts will not hold it nice and flat against the thing. And if you have ports that protrude too far, obviously it won't go into a case properly. So those are just things to consider. Again, I'm not going to over tighten these. And of course you could just, you know, paint that bit of metal. I may do that at some point. I might take it off, give it a sand, get some primer on it and spray it. Maybe silver or something, I don't know. But anyway, there we go. Right, so yeah, so still a lot of cleaning still. It's dirty, look. Horrible. But I think the next thing I want to do is try and deal with this. I'm going to see if I've got any new 174s there. We've got the old resistor array here to clean up and test. 3 or 4 traces to fix around there, I think. And, oh well, trim cap. Let's get the trim cap back on. Yeah, so you can see the 174 was a large chip. It's not one of the smaller ones. You know, you've got SSOP, I think, and then SOP. So it's interesting how it had the larger 174. Did someone try and swap that out? I don't know. I don't know whether I dare try and reuse that. So we got one of the original 166s here. Hang on a minute, I'm really confused. Maybe that's the 174. What's this one? Oh, that's the 245. Yeah, ignore what I'm saying. That's the 174, but nevertheless, look, it is bigger than the 166s. The 174 is usually the same as the 166. So we got the old nuts here from these ports. Look at those. Yeah, would you like to reuse those? I will clean them up, but seriously, I'll spend like half an hour, look at that, I'll spend half an hour cleaning those up and ultrasonic them and everything. Yeah, so we also need to clean, hang on, the legs on the lock chip here, the recoat, and there's the pinheads, look. Yeah, I wouldn't want to reuse those again, green and furry. So just soldering on the trim cap, which we've tested and we know is good. And clean the solder points up around that. So the next thing is this crusty IC. Let's give this a clean. So I'm just going to use the fiberglass pencil. Use the leg straightener here that came from Cathers. That's just squeeze and press that down. Yeah, hopefully you can see the pin's looking really good. I haven't even had to use desolder braid or tin them up. Most of the corrosion's come off. I will just, however, have a clean on the inside here like this. Right, I've anchored the one pin down here. I'm now going to try and come in left-handed, and I am not left-handed, or ambidextrous particularly. Yeah, I'm going to get onto the, hang on, pad. I haven't really got a depth perception here either because I'm using my right eye only as well. Left hand, right eye. There we go. I've anchored the other point there. I'm going to use the Antex iron again for this, but just get some flux down here. I tested all connectivity around this chip and everything is good apart from the 2 traces that go to the resistor array. So I'm going to deal with those with a bit of coil wire. I'll route them, put them through the holes, then solder the resistor pack on. The resistor pack's been cleaned up, we'll test that in a minute. And I've got a brand new 174 here. I didn't have any LS ones. Now, I've seen HC ones on these before, and I've seen LS ones, and I fitted HC ones in the past, they work. So, yeah, it's just I think it's just a bit of a dress decoding for the chip, that's all it is. So, anyway, yeah, I'm not fitting the original one. Anyway, the solder iron is pretty much up to temperature, I think. So let's get some solder on the tip. So I'm going to start up there, just bob in a little bit, and then just drag slowly down like that. That's one side done. I will just inspect it to make sure it's alright, and then same on this side here. Just drag slowly that way. I'm trying to be careful not to redo the solder points here because that's alright. Right, so I've fixed those 2 wires there. I'll secure them down after we've got the resistor array in place. So the final thing is to test from the common pin, that's where the dot is, to each point on the resistor array. It's 10k. This I've got 10k. Test the next pin. 10k. 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 So the resistor array is good. Pin 1 is to the left. The wires, as I said, they're laid out on the PCB here, the exact distance, and they're through the holes. I need to each one for a few seconds. Oh, hang on a minute. Just to melt the coating off. Otherwise, they won't actually join at the point where they're going through the holes at the moment. in position. I'll just inspect these wires. Yep, they look good. And we'll secure those, as I say, in a minute with UV solder mask. So I believe this is the last component. I believe it's the last issue. I fixed the joystick port earlier. I haven't tested it yet. So yeah, once we've got this on, we've got a few things to test. Clock, floppy drive, serial power port. Just make sure that's nice and straight. So this next one's got a wire, so I'm going to heat this for a number of seconds. And obviously we can test on connectivity on the multimeter in a minute, just to make sure it definitely is going to the chip. But as you heat that there, the coating's melting off, I think. So I think that's joined. This one here is the same. We need to heat for several seconds at least in order to melt back the coating. Right, that's it. Resistor array's on. So of course we've got extended bits of wire to trim off here. You can cut them, but what I tend to do is just grab it. Hang on, I can't see which one it is now. And just wiggle. Like that. That's it, and it's gone. There you go, because it's coming out of the solder point, so you can't break the trace off or anything. So I'm confident that's going to be alright, but we'll test connectivity. Let's just clean first though. I'm going to clean. Man, I procrastinated over this one for so long. Yeah, this bulb was picked up probably 2.5 years ago maybe. It's incredible how long it took me to finish it. Right now let's just flip it over and test those 2 pins on connectivity. Yeah, so that one's joined. Let's test that one. That's the next pin, I think, isn't it? Yeah, the big problem doing this is trying to get a probe underneath that resistor array. Bear in mind it probably goes to the chip up here, so you can probably measure that way. Yeah, I know you can't see what I'm testing there, but that's joined to the chip, and then that one is the one that's next to it there, I think. Yeah, that one isn't joined, so we just need to just flip this over again and just flow yet again. And that one. That's it, both joined. Yeah, I may have tested those the wrong way around, like moved to the right on the array, thinking that's the next wire, and it's actually the one on the left. I don't know. But anyway, that is looking good there. So I'm just going to carefully clean here with the cotton bud and IPA. As I say, those will be covered. Yeah, just clean under here again, where I just reflowed. So first power on after doing all of that crazy stuff. Let's just see if we get the sticky disk in screen, then I'll connect up IDE. Yep, there we go. So place your bets. You think I've fixed the clock? I don't know, the clock is painful on these, it really is. It's like you can think you've dealt with every trace around there, and then you find out, no you haven't. You haven't at all. The clock doesn't work. It's probably going to be like one of the traces that goes all the way from Gary or something on the underside. That's balked. That's what usually gets me. Right, let's try again with IDE. There we go, it's been from IDE. We've got 256 meg Zorro free card fitted as well. Let's plug in the mouse in. I want to test the joystick port first, I think, and then connect a floppy drive up maybe. Oh, hang on a minute. It's black screen booting now. Yeah, so there is definitely something else going on here, because I had this before, and the one thing I found that solved it, funnily enough, was actually taking off the CPU card. You see, it kind of looks a bit white here, so I think there's some corrosion or dirt or something in there. And then often just by virtue of reseating that, it would then boot. I'm hoping that's what it is. Yeah, it would seem that's the issue. I think. Hang on a minute, is it frozen? No, we do have some kind of issue here. Is it the RAM? It could just be a dirty slot here. I mean, we don't need that RAM, do we? We've got the Zorro RAM. Let's just reseat the chip RAM again. I think last time it was just the CPU card. This time it looks like the RAM, because I think that's... Oh, hang on a minute, it's frozen again. No, it's not. It was just slow there. Yeah, there we go. We got our Zorro RAM. That's good. So let me load a game again. Let's see if up is working on the joystick. Wow, that's so slow. And I think it's because it's having to use the Zorro RAM, actually. Yeah, there's a definite big difference there between the RAM it's using there versus the RAM that comes from Ramsey. Is this going to black screen or not? I don't know. Yay, there we go. Hit fire. Sounding good. Yay, you can jump now. So I'll connect a floppy drive up and we'll just see what's going with the real-time clock. Floppy drive precariously balanced upside down there, pin 1 to the right according to the PCB. See if it boots from floppy. Yep. God, that took ages. I thought we were going to have a CIA problem or something there then. So let's just see what this reports. So the memory should see the Zorro, yeah, 256 meg there. Come on, real-time clock. I bet it doesn't work. It says invalid. Reset. Now you see it's not incrementing, is it? It's not incrementing. Save and exit. Yeah, it's not incrementing, which is a wee bit concerning. It could be a bad IC, this is the thing. Then again, it's detected it, hasn't it? But from experience, this is where you just need a little trim cap adjustment, because as soon as you adjust that trim cap up, we'll start doing something. So it's the 29th of April, let's just set it. Warning, invalid date time. How is that an invalid date time? It isn't. It needs a reset. It doesn't need a reset. So, it's weird how it's detecting it, isn't it? But when you set the things there, then it says it's invalid, so I don't know. I actually think I'm just going to try and get hold of a new one of those chips. I mean, I can try and reseat the chip. The other thought I had was the trace that goes to the pin here, this little wire, because that always breaks. I'm just going to test the one trace that goes down on the side there, actually. There's like a wire right next to it. That always breaks, and I was surprised that when I tested connectivity it hadn't broken. It's joined, so I don't know. Maybe it's one of the wires there's not been through to the other side or something like that. Now I've got my loop backs here. The actual pinouts for these are covered in the software, you'll see in a sec. These are well worth assembling. And you can just build one of those adapters really easy, just a 25-way, either male or female. You know, you need one of each, one male, one female, with a hood ideally. And you just join several wires in each one. Now this problem where I'm getting this black screen, it's actually this monitor, I think, actually. I've had this problem before with this. If I switch over and then switch back... No, it's not. We are actually... Oh no, it is. It is that monitor. There we go. It's just that monitor with that cable. If we... so there isn't a black screen issue, there's not a problem where it's intermittently not booting, it's just the cable. That confused me for quite a while. If we now go serial parallel, let's do serial. You can see here, it shows you join 2 to 3, 4, 5 and 6 together, 8 to 20 and 22, but they're all green, so the serial port is good. It tells you what they are here. Yeah, so like pin 2 and 3 is common to know what those are off the top of your head. It's receive and transmit, TXD, RXD. You can create a basic null serial interface, a null modem serial interface to another system by just sending 2 to 3 on the other system and 3 to 2 on this system, and then the receive goes to transmit, etc., vice versa. You can communicate that way, and then some of the others are control signals and things here. So you've got RTS, receive, I forgot what RTS is. CTS is clear to send, something to send. I'm not sure what the R is. What's 8? 8's CD. I've got no idea what that is. 20, 21. 20's DTR, dial tone ready, I think that is. That's from when we had modems. 22's RI. Is that ring? I'm not sure. Anyway, if we go back and look at parallel, so you can see there's quite a few more here. So 1 to 10, 2 to 3, 4 to 5, 6 to 7, 8 to 13 and 12, 9 to 11. So yeah, again, it's green. So serial PAL ports are all good as well. So the only issue we're left with then is just as the real-time clock. And I think that's probably going to be a broken connection or a bad chip. Scoping the crystal on the real-time clock here, I've just scoped everything there and everything looks alright. apart from here on the crystal. And to be fair, it's not just the crystal. I saw no clock on the chip. But anyway, if I probe what I think where it should go, I think it's there next to the supply pin, and it's just like flatlined. Well, it's like high, and that's like high is again. If I actually probe the crystal and just watch this, watch the signal, watch. See how it starts to oscillate. That's me having a bit of load. I think we've got a capacitor maybe on the underside not joined to one side of the crystal. So there's not, it needs that load on it. I think that's the issue. So I think if we scoped this now when test kit's running, the clock would probably work alright. Yeah, and you can see that if I pull that away and then scope where it goes on the chip. This is on the chip, hang on. Oh, it stayed oscillating now. What happened before was when I pulled away like that, left it for a few seconds and then touched the pin, you can see it just diminished. There was a little bit of it still there and then it went away. So it's like we're jump starting it by probing the crystal, then going back to the pin. The capacitance on the pin is keeping it going. If we pull away from the pin, yeah, leave it for a few seconds, probe the pin again, it's gone. There you go. So I think that's the problem with the clock. I think it's missing a cap on the underside somewhere to one pin on the crystal. Right, so there might be another issue after this, but the crystal points come out here. The first one, it goes to a pin there, and then it goes to pin 16 here, I think. Yeah. So that's one side of the crystal. According to the schematic, that's correct. I'll show you that in a minute. The other side of the crystal here should go to that cap. Hang on. Which it does. And then it should go to that cap, which it doesn't, which comes to this pin here, I think. 17. Yeah. So the cap to 17 is connected, yeah? But there's no connection between here and there, or here and here. So, yeah, I'm just going to run a wire from there to that cap, because that cap is joined to 17. That should then mean that the crystal will oscillate. That's why me probing it was starting the oscillation. It was missing the cap on one side. The capacitance from the scope was starting the oscillation, but nevertheless it didn't have both connections to the chip, so it may not have worked properly anyway. And that might not be the only issue, but anyway, let's just fix that. I'm very pleased there. And everything else around there, and the scoping I did on the clock chip and on the 174, kind of looks alright. So this may just spring to life. And you may think, well, if the oscillation wasn't working, we know that because it wasn't counting up, was it? The seconds were not incrementing. Would that cause a problem with it having the wrong data? Because it kept saying it needed resetting, doesn't it? It needs initializing. Well, yeah, because it's kind of not really an MCU, but it's a device that is processing, isn't it? You can communicate with it and tell it to store, tell it to retrieve. It'll pass the actual date, component parts back in some sort of way to the data bus. So yeah, that is probable that is just the issue. There's nothing else wrong with it now. There we go. So I joined it to a cap. That's it, it's joined on that end. I'm just going to press the wire here and reflow there with a bit of flux. That's it. Clean up with a bit of IPA and we'll test the real-time clock again. Right, let's just test connectivity again now. Is that pin on the crystal joined to 17 on the chip? And it is now. And that one should join to 16. There we go. So at the very least we should get oscillation at 32.768 kilohertz. Yeah, and it is the rigmarole having to connect all these cables and things up every time I test. I haven't got a floppy drive connector at the moment. I really want that for test kit. Anyway, we'll see if we can maybe set it here maybe, I don't know. Hang on a minute, why is the mouse not working? Oh, I've got the joystick plugged into the mouse port and vice versa. Yeah, I'm not sure what's going on here, because if I'm honest, I still don't see any oscillation coming out of this. I mean, we can probe the crystal again, I don't understand why I can't seem to scope it, but you know what, the time it is incrementing. But that could be from the timer rather than the clock. Can you see it, 1547, the TV's 1548, so yeah, they're about a minute behind, but it is actually working. I think we need to boot from floppy again, don't we? It's the only way to be sure, really. I'm just not sure why I cannot seem to scope it. The scope's on times 10, so I don't know. Hang on, what's going on with the mouse now? Well, that's a new thing. It's on Amiga. The mouse has just suddenly stopped working in one orientation here. So, do we have a shift register problem, or... Oh, that is really blooming annoying. Why is the mouse now in issue? It's not the cable, is it? Right, so a different Amiga mouse here. No, there's a problem with the shift register or something like that. Oh, that's blooming annoying. Right, since we can't use the bloody mouse, I'm going to use the Amiga 4000 adapter that I created in the video with the Amiga 2000 adapter that I created in the video, which goes to an Amiga 500 keyboard. I got that, so it's 500 to 2000 to 4000. We need to test the keyboard anyway. I just don't know what's mysteriously just happened to the mouse, to be honest. Because, again, connectivity is really good, and it's been solid on all the time I've been working on this and testing it. Right, let's try with the keyboard. Yeah, it's not incrementing again though, is it? I'm sure that's supposed to be incrementing there. Let's do set time date, F2. Escape, save and exit. Invalid date time. I think it needs a new chip actually. I'm having a really difficult time trying to work out what is going on with this. The conclusion here where I think the original shift register, this is the one I took off the board, even though it wasn't corroded, I think it's failed. I can't see what else it is, because I'll show you when we get beyond this if this doesn't fix it. Logic probing around here and connectivity test. We go high low as we move in each orientation there. And furthermore, yeah, God, trying to get that to stick down is near impossible. Yeah, furthermore, the connectivity is there to the caps, to the shift register. It's the same in both orientations. I've scoped it. It's like, it doesn't make any sense. Just that one pin. So all I can gather, or theorise, is that on that one pin, it's not reading that input. So anyway, we'll swap this out. I have got one more of these new. If this does fix it, it just goes to show, don't bother using the original ICs at all. You just set yourself up for a fail maybe. But I've got this theory or this feeling that that's not going to fix it. You'll know yourself, and certainly from watching my videos on these, is that when you get problems with the controller ports here, it can be a direction you don't think it is. So like, you know, we're looking at one orientation here and I can see activity, but you may find it's the opposite direction that's got some problem, like one of the caps is missing on the other direction or something. And this is the thing, it can totally throw you off. You know that from the diagnostics point of view. You get a problem with one connection and you're suddenly getting diagonals. You're moving left and you're going up and left, and you're like, how's it giving me an up when all I'm doing is hitting left? Anyway, it's no worse for wear in terms of removal there. Let's now just mop up the solder. And there's a trace that runs right along the edge of the board here that's not connected, or wasn't connected. I've fixed that. That had nothing to do with the input here. Right, let me get a new 166. Yeah, there we go, last 166. Please let it be this. I'm getting cheesed off, I've been on this for blooming ages, this machine. And that's one pin. There comes a point where when you... See, I was enjoying working on this, now I'm not. I hate it. I actually hate this Amiga. I might change my mind when it's working. Right, so let's try it again to make sure nothing's showing. So place your bets. I'm thinking this is not going to make a difference. I think I'm going to spend ages looking at this now. Oh, it's working now. It was the shift register. Oh, God, can you believe it? There you go. Don't use crusty old parts. That's what it was. I'll try and find the ball for my mouse now. It was extracted earlier. Oh, here it is. It's a relief to be able to use the mouse again, I'm honest. Oh, it's really annoying that I can't find shit today. Where's the trim cap tool gone? So I'm scoping pin 17, I think it is. That might not be the right pin. And then using the trim cap tool. I'm just going to try and rotate it. We want 32768, don't we? Hang on. I'm going the other way. Yeah, as I use that trim cap tool, you can see the height adjust there. I think what we're going for here is an optimal peak on it, so like about there maybe. That's as optimal as you can get. Anyway, it's incrementing on time. I'm just going to boot test kit again. Yeah, I always test the same things beneath a steel sky, CD32, down to 170 meg there. It'll go a bit further, it's almost finished loading. And it's taken about 20 minutes to load that with a stock CPU. And do you know what? I think at the end of that process we've got a black screen, and that's the Kickstart 3 thing. So I honestly don't want to load that again. I'm sure that's what it is, because this is what you get with WHD load and Kickstart 3. Right, on to the final cleanup now. So I've got some flux around various parts here where there's odd bits of copper traces and things exposed, but also where there's the odd cap or resistor that needs reflowing. Just cleaning these standoffs here where corrosion's just got onto them a little bit. Yeah, there's just the odd pad that just need a little tin. So I've been very careful not to damage the wires there. Going to put some solder mask on those in a minute. Yeah, so it is still pretty smeary down here. There's a wire here just to move like that. Just make sure it is still joined up. I need to check on the schematics where that goes actually. What does that fix? The 3 wires on this side for the memory are still in position. So before I secure these things with some UV solder mask paint, I am just going to, clean manually here with cotton buds. Yeah, I'm not going to go crazy there. So a bit of UV solder mask paint here and over that wire there. One of the final bits of UV solder mask here. Hang on, I'm nearly setting my arm on fire on the soldering iron here. There's still a few bits to do, but not very many. But 150 degrees. Hotter will obviously cure quicker. Airflow, you don't want too high. I'm just going to get a wee bit of deoxit onto the end of this cotton bud here. Maybe just squash it a little bit flatter. Of course, some of the deoxit comes off when you do that. Just very gently, there we go, get in between those contacts there. And have a very slow slide up and down those, just twist marginally. You've got to be careful because if you snag one of these, you'll destroy it. Yeah, there are little bits of dust inside there. But anyway, the slot is super clean now. So I'm just about to hoover this down, but a quick look at the board now. So it's got the original ports on the back there, new joystick ports. It's looking amazing actually. It's looking really clean and glossy. Yeah, so original SIM sockets, obviously new capacitors. Got some solder mask paint over a few things tactically here, and obviously down there with that fine wire. Yeah, so there's the odd streak and stuff still, but I think you'll agree that has come out really well actually. Yeah, and the SIMs are totally reliable. But I will just hoover it because there's just the odd particle of dust and stuff on there. Well, I'd say it's pretty stable. I've been playing it for, well, a long time, as you can see. Around 74. Oh, I'm not sure if I had the shoe, because once you get the shoe, yeah, I did. You walk too quick, and then it just makes it really hard trying to. Oh, I've done it again. I'm trying to time. Anyway, well, I get to about 80 or so, or 79 or so. 81. Anyway, I think we can say it's stable. So the next thing we're going to do here is fix this up really. It just needs a wee bit of flux and resoldering of these arrays. I'm guessing it's had a repair, I don't know. But you know, we did have the 2 pins that were not soldered, that was the problem with the top slot. There's obviously some bodgy solder down here as well. So I'm honestly not sure what the story is with this. Maybe someone had a problem with that top slot right from the start and then proceeded to swap out the resistor arrays. This is the odd long leg there that needs trimming down, look. Yeah, I thought I'd just show you some of this up fairly close. I just cleaned a lot of the flux off here, but can you see these like bits of solder around there, a bit of sticky label or something, and it just looks awful. All of the resistor arrays on this look like that. And there we go, that's the end result. It's looking pretty darn clean, that now. So they look like they haven't had a lot of use, these slots, to be honest. I cleaned the top slot with deoxit already, but I think let's just go down the slots and clean them with this. Get my 256 meg Zorro 3 board in that I bought from Sparks UK. And as usual, the through-hole caps are fine. That did a ding-ding, which means the ESR is really good. So that's the other one. I mean, these are not great brand, like Shui, I think. Same again, ding-ding, good capacitance. But the SMD ones, every single one were balked. There was no point in even measuring them. And incidentally, the cap kit that I got from the Amiga kit, that kit needs some serious work. What I mean is, half of the capacitors, they weren't on the chart. I had a little chart, it was like A to F of different capacitors, and it said A4000. And I couldn't find some of them at all on the list. There's like 4 or 5 that just were not listed. So I had to use another guide somewhere else. The through holes in that kit, by the way, are FR series, you know, Panasonic FRs, so they're quite good. Weeks later, we've got some real-time clock chips here, I think. RP5C01 Ricoh. Yeah, I've got the wrist strap on here, by the way. Let's use the leg straightener from Cathers. Amazing little thing. Just because they're gull-winged, you know, they're spread outwards at the moment. And let's remove the old chip here, because this is the, I'm trying to remind myself now, because it's been weeks since I looked at this. It was, when you set the time and date, it then said it was invalid, didn't it? It was corrupt to it. So I need to squeeze it a little bit, I think. So we'll test each of these chips here. I'm just going to switch it on with my finger on there. Make sure it doesn't go nuclear. Right, it's booting up. Real-time clock, so it says detected. Reset. I mean, it's incrementing here, isn't it? It's work fuck. There we go. So it did just have a bad real-time clock chip, I think. And I'm not going to know until I battery mod it and stuff, but yeah, right now that is not what's happening. Straight away after setting it, it would get corrupted, the year would be wrong, the date would be wrong, everything would be wrong there after saving it. I need to get a bit of UV solder mask around some traces there, wire, yeah. I need to clean all up this area. I need to clean all around here, like toothbrush in between these things here. But I've got a CR2032 hold here and a low forward switching diode there. It's like 0.125 volts. There's just little bits of hair and dust and stuff, and using the microscope I can see them really clearly, and I can show you some of that stuff with the microscope afterwards. So I'm going to put the meter on continuity. I'm just going to rush through this. I've done it all before so many times. There's a mod you can do on these to fit a diode across 2 connections here, like an additional diode. And I believe, and it was Stephen Leary that pointed me towards this, it's something to do with some of these Ricoh chips, or certainly certain board revisions with certain versions of the Ricoh chips, where I think it doesn't, or it outputs on a data pin or something before the reset's fully had time to kick in, or something like that, where it can cause it to boot fail, yeah? I'm wondering if that's the problem with my other 4000 board, the one from Stephen Leary actually. It may have had that diode on from factory, and I may have removed it going, what's this? This is a bodge, and never put it back on. So that's something I need to think about on that other board, but nevertheless I thought I'd just mention that. and I appreciate I'm being a bit fuzzy on the details there. Anyway, I'm just going to measure these here, just try and find where the ground is. Yeah, so the single pin on its own is the ground. You know, it just feels like concrete. You get, you know, like oxides that form on top of these things. That's the thing I talk about, where you've got to scratch it with a scratchy tool generally. So there's there you go, it's flowing now. There's an element of that. I don't want to use the dissolved station because that bit will get sucked up and very likely block it. Yeah, and if you've not got one of the little PCB adapters to go with something like this, you need to bend the legs marginally so that it, you know, it fits away from the edge of the sim here. There we go, I can feel that that's in the right place now. So both those mounts are okay, and with a little bit of a gentle persuasion you can sort of get it to sit off the board a little bit. Hold it in place like that. I might just need to reseat it depending on how this solder flows. And if we just heat here, just give it some time to go through to the other side. I'll have to inspect with magnification to make sure it's gone all the way through up the leg, and it has, because I can feel the leg heating up. And then we'll do the one here, and the only other thing, like I say, maybe just to reheat this, to straighten it, if I feel, like I can feel the pin heating on the socket. Ow. The battery socket, that is. So there's, you know, a tiny little gap there of about 1mm, but it's in position. So that is that bit done. Where you've got the two contacts, well, three contacts on the one side of the battery there, the positive, it's actually marked positive, goes up a big rail here and then goes to that side there of R179. The silk screen's worn off on my board here a little bit, but it's not making it there. No one's going to want to revert it to use, you know, a NiCad battery. That's not happening, is it? I need to get all the way from here to there. I'm going to need a wire, aren't I? So it makes sense to have a wire from here to that resistor point, remove the resistor and just fit the diode there like I usually do. I found a red wire that I'd cut off something recently. I'm going to solder it on down here. Now these three contacts here, they should all be joined together, but they aren't. I'm not going to join them up. There's no point because we've got the battery, you know, mounted already. I'm just going to heat this point here and join the wire there. Like that, and then it simply needs to join. There's a rail here, you might be a bit far out. I'm going to route it all the way over there, because the thing is, when you've got, I talked about this in the previous parts, when you've got these solder code traces like this, if you've not put the UV solder mask on there, well, you imagine a wire like this, you know, coming out with strands, it could just lean over some of those there and join the, you know, the battery rail up to one of these other connections. So it's better to just stretch it over here and mount it directly to R179 where there's nothing nearby that, you know, there's a potential to join onto. The solder points can look weird, you know, like if you look at it like that, you can see the solder points are pretty good. One or two of those components are a wee bit crooked. So, you know what, I'm going to heat with hot air. We'll try and straighten one or two of those things at the same time as pulling that resistor off. There we go, got it. That was actually incredibly easy using Commodore Cam. So, as I was saying, I think we'll just take the opportunity here just to try and straighten these if we can. That's glued down like that. That is well and truly not moving. I think I'm just going to leave it like that. I may even try heating with the iron actually, because I don't know, that's not moving. And again, I've shown this before, where the best thing to do with this is to trim it like that, really short. So it's this rail here, this rail comes all the way up here to that pad. So this is where the anode wants to be. That's the side without the band. So you can see it's perhaps, well, it's just about the right size for that. Right, that's kind of it, just further this way, there we go. That's it. So you can see the issue there, it kind of floats. The angle can reflect the light in such a way as everything looks dark and horrible. But the board here does look good. Other than that component there being a bit crooked, it looks really good actually. Yeah, that's pretty good. It doesn't look it. You got to remember though, this has had so much damage. You know, if I just tilt this, you can sort of see a wee bit better. If I just change the focus. This is what I said about angle and how light can reflect. So yeah, that diode did get baked a little bit, but you know, you've got all these little marks here of, you know, heat damage where you've tried to desolder, etc. There's the odd bit of hair. You're never going to get away from that. Anyway, let me now check that that is all good. We've got a couple of wires there that really need a wee bit of UV solder mask on them. But I have my voltage drop. So this is the positive side of the battery here, and it should go to this corner pin up here. There you go, 0.344. Yeah, should be, I don't think anything the other way around. Yeah, there we go. And then this should be the ground, so for test 2, I don't know, ground pad there. Yep, so we've got that. So if we stick this in, now this is the key. Is this gonna, let's just measure this voltage first. Is the battery level going to drop instantly? If it does, it might be we're powering something we shouldn't be doing. 2.8 volts. So let's put it in. Now I'd expect some drop because it's a low battery. You know, it's not exactly fully charged. I need to just bend this tab like that, marginally. That's it. Let's now measure from ground to that corner pin up there. There you go, 2.56. You can see it's climbing. That shows me that the inrush has passed and the capacitor is charging up. And if it was dropping rather than going up like that, it's a big clue that it's powering more than the real-time clock chip. But the fact that is going up, you know, what happens is you get an inrush to start with, it'll drop, it'll go right down, it'll plummet, the voltage drops, you know, by, I don't know, 0.2 a volt, 0.3 a volt or more, and then it starts to gradually start to climb back up. And it's like I say, it's about the inrush of that cap. As that cap gets most of its charge straight away, you get the drop, but hang on, it should then start to climb, and it has done 2.57 now, and it's stabilised there. So I'm confident that that battery mod is okay. So we'll boot Amiga test kit, I'll set the time and date, and let's see if it's retaining time and date. And there we go, it's kept the time and date, 10:58, 10:58, it's about to go 10:59. I'm not sure whether the TV is ahead of this or behind this, actually, so they might not go at the same time. Yeah, that's on 59. This is a wee bit behind. 59, there we go. So because this is like, I don't know, roughly 5 or 6 months later, in terms of the bits we've just done there, just tested all the RAM out, all 16, well 18 meg, checks out okay. The sound is alright, I tested the filter again, everything's good, it just needs the final clean up, and I can give you some close-ups on some of the fixes and things. Yeah, so it ran fine for a couple of hours there. And the next thing I'm going to do is just focus on cleaning up the areas of the board that really haven't had any work whatsoever. If I just adjust the light, there you go, it's like that without the light, look. You can see here, it's pretty blooming crusty. So I'm going to clean initially with cotton buds, just to try and absorb a lot of that rather than just brush it around. But then I'm going to move on to, if I can find where the cotton bud is, yeah, then move on to using toothbrush. So I'll just collect what I can this way. But I think you can see that that was looking immaculate. So that's the sort of level I'm going for really over the board. So the parts I didn't put back on here. You know, we've got the one of them I did, the 166. We've got two 166s. One of them went back on, was faulty, the other one was pretty dirty, so I fitted a new one anyway, so it ended up with two new ones on. And then we've got an F245 here. This is the one that was for the RAM there, that's right next to the battery. It's really green and corroded, so I mean I could keep that as a spare. I'm not even going to clean it up and keep it as a spare, I'm just going to put it in with the faulty chips actually. Yeah, and finally the 74 for the real-time clock decoding. And last but not least, the Ricoh RPC501, is it? Yeah, it's an RP5C01 actually. So those can go to the faulty components here, of which there are now quite a number. But technically speaking, that F245, I bet it's alright, and the same with the 74, but yeah, everything go to the component graveyard. The crystal, I didn't fit the old crystal back on, but I cleaned it up and it looks good as new. So I'm just going to put that with my watch crystals, and it'll get reused, that watch crystal, on something else. You tend to find if the corrosion hasn't got right into, you know, the actual body and it actually works, it'll continue to work. It's not quite the same as a normal semiconductor like that F245, for example. It could have been used with the corrosion there, which means one of the transistors that drives the high, you know, a different transistor for the high and the low, you know, to drive it one way or the other. One of those may be subtly damaged. You could see it on a scope if it was, but the bottom line is, you could stick something like that F245 on a board and it's working, and you go, oh, there's nothing wrong with it, it works, yeah. And unless you scope it, you could see its logic level's a bit low when it's, you know, going one way or the other. So it's not even worth it. It's just not worth it. But you could argue it's not worth using that crystal, but the point I'm trying to make is where something like this is, you know, even a resistor. If you had a resistor and a bit corroded and you cleaned it all up and you can see it's not gone into the actual body and the resistor measures alright, the resistor's going to be fine, which is why I'll seldom ever replace through-hole resistors unless they're totally balked physically. Yeah, anyway, that'll get reused. So I think I showed the case in part one actually, but you can see the original case that motherboard came out of. There'll be a link top right to the video where I fitted the board that came from Stephen Leary into that case. I might ultimately swap them around, I don't know, and use Stephen's board as my test board, and it'll feature on the bench a lot more that way, I'm not sure. But I do plan on doing a fifth part where I just do some testing of this board. We can test some different CPU cards on this. I've got another build of one of those coming up thanks to all of the people in my Discord, which is absolutely amazing. We're going to be using this 4000 to test a number of different Zorro cards and things, so there's going to be more of that coming up on the channel as well. And I've got an A1481 video coming up as well, which was an amazing gift from all the guys and gals in my Discord again. I can't thank those people enough. There's some amazing people that support me. I just can't honestly thank you all enough. You're all absolutely wonderful. So you can see here now, looking at this close in the light, you can see it looks nice and glossy. There's no signs of solder or flux or anything. Yeah, sorry, I knocked the camcorder there. I forget exactly where the connection was now. I think it was one of these slots up here was just not soldered. There was 2 points that they were, it didn't look like the solder had been removed. Yeah, I wish I'd had a really good macro shot of that, but they were just perfect, like they never had solder on. And I think it had a problem with that top slot from manufacture, and I think somebody tried to fix it by bodging, you know, new resistor arrays on. You can see where the resistor arrays are there, and if you look at the solder points on them, they're absolutely pristine. That looks like new, I think. It's hardly had any use, that. I'm really pleased with the way I was able to reuse the original sim sockets here, and you may question that as a decision, you know, if you're going to, you know, try and fix something like this, new things are better. But I kid you not, it's like these have been in there for ages, and you can see there's no corrosion on them. That they look absolutely pristine, even though it's like a few months later since those have been out, but they clip in really well. These have never been utilised. I think the way it came to me, this board, it just had the original 8 meg sim, not this one. You know, this one's steps up a bit higher, and I've got the sim that came on this board in my cased, you know, the Stephen Leary board actually in the other machine. But the point I'm trying to make here is, despite the fact these were super green and horrible, looking up close at them, they look absolutely pristine. So the number of washes I did with vinegar, with IPA, the ultrasonic, scrubbing them carefully with the fiberglass brush and the wire brush, and then rinse repeat, doing it over the space of, I don't know, 18 months. You know, they must have got cleaned half a dozen times each, these sockets. They came out perfect. They're just so reliable, and the key why I want to keep them, they looked correct. There's no melting marks or anything like that, and as you push them in, they click like that. Those are the best ones of these I have come across. Every one of those, they just click like that really well. Yeah, so I've marked it up fixed 2023. I'll just give you a quick look at the board. Yes, I think I've got most of the dust and fluff off here. If you have a look at the corrosion area up here, it looks pretty darn good, I think. There are a few places where, and I might do this off camera, I'll show it in the next part perhaps, little bits like here, maybe a bit of solder mask paint there would be beneficial. And if I just flip this around this way here, there's a little wire somewhere here, and I actually think I should just get a little bit of UV solder mask paint there as well. And you could argue maybe up here, but I think in general It's just come out amazing, it really has. I mentioned this earlier on where it's got a little bit orangey here in places, but if you look at it, yeah, it's not too bad. So what I might do in a later part is take that off, sand it down, primer, spray it. I could zinc plate it, electrolysis, etc, but yeah, I think maybe just a quick paint might be the best option. And the bottom end of the board here, you can see, you know, I toothbrushed all around all these things here. You get lots of dust and dirt and stuff in between the pins, and yeah, it kind of looks almost like it's come from the factory, really. There's obviously some, you know, telltale signs of corrosion and stuff here. If you look at this plate on the back, it's not perfect, but you know what? I think it's incredible. I would have never imagined that I'd be able to do that level of repair. So you can see, you know, there's lots of wear marks here if you look at that in the light, where the fiberglass brush, you know, is the thing that does that, and we've got UV solder mask paint on a few things here. Lots of exposed bits again around here that could benefit maybe from UV solder mask paint. One or two of the components, as I sort of showed when I was doing this here, are crooked and they're glued down, they're epoxied, they were like that from factory. And it's the same with all of these. If at any point you've noticed, you think, oh, some of those look crooked, they're stuck down that way. So yeah, I could prise them off and stuff, but it's just a bit of risk. I'm not that fussed. I have seen some of these where they seem to be assembled a bit slapdash, where the components are just slightly to the side on the underside here. So that's just one of the issues from factory. And then we tinned, you know, I've tinned up anything here, any odd wires. I spent a lot of time tinning up the odd wires around there. But getting you a close-up view like that, hopefully you can appreciate it's pretty good. Yeah, a bit bodgy on the points down here. So I mentioned that in an annotation, I think, in a previous part. The best way to fix that would be the way I did the top side ones, which is to put your kynar through the wires here, lay them down on the traces all flat, nice and straight, and then mount your chip on top, yeah, and solder everything up. And because then the wires are actually on the traces and it looks better than going up the leg. But I tried to show you two different techniques, so that was a deliberate thing. I knew it was going to look a bit bodgy. Obviously we got a new real-time clock chip there, that was faulty, and obviously a full set of capacitors, and the jumpers that were affected here were replaced. These ones were okay here. Sometimes you get more corrosion here around Alice, and sometimes you get more corrosion around Paula, but on this occasion it came out pretty good around that area. And similarly, you know, this area here, I think got away fairly well compared to certain boards that I've looked at in the past. And another area that can get affected is around here, because these two caps, you know, it's a bit of a confined area. So yeah, I did reflow these things. They don't look quite as good as they could do, but anyway, everything here has been toothbrushed and super cleaned. And I did find my Kickstart 3.1 ROMs here. You can see those fitted. I got those with the intent of putting them on the board that came from Stephen Leary, but when I eventually got the A3640 PCB from Stephen Leary, I got with that Kickstart 3.9. That's what's on my cased board there. So these 3.1 ROMs were available. The funny thing with those is they were the very, very, very last chips in my box of ICs. It must have taken me 25 minutes to find them. I will get a heatsink onto Alice later. They don't tend to get as hot as some of the Agneses do, but yeah, that does get warmer than any of the other chips on here. We will revisit in another video as well, because I plan on fitting a gal here and doing the mod where you remove Ramsey and do a little bodge there, and you can then fit larger sims like 16 meg sims to give you, you know, 64 meg, and I think you can also do 32 meg sims which give you 128 meg. In addition, the other mod that I will do that you could consider is you can change the code on one or both of these, I think one of them, and gain PAO mode 2, so it just improves the speed of the IDE. And finally, the TLDR summary here is, with corrosion repairs on these, Amiga PCB Explorer is where you should look at, you know, to consult the layout of the board and just test connectivity. You know, do what I did, got everything around here, maybe even as far as up here, if you've got more corrosion up here, and then just test connectivity on everything. Replace the chips, don't mess around like I did putting the original one on there, despite the fact it wasn't very fuzzy. It'll just come back to haunt you, and if it's faulty, you're going to have problems. These things are not very expensive, you know, maybe £1 an IC or something. The Rico's a bit more expensive and harder to find, maybe £3 or £4 each, those. GALs, you'll need something like a TL866 if you want to get a new GAL and program it up. Pay attention to the speed of these, that is important. You know, it's marked -15, I think, that one, but they're not all the same on these, so maybe just replace every component, and then as long as you've tested the connectivity, you should be good. But in a later video I'll talk about some of the issues that other guys on my Discord have had. I need to check with them first if I've got their permission to discuss some of those things, but Stefan and Pillock work on a number of these boards, and a few other people as well, and there's been all sorts of problems they've had, and I think it'd just be interesting to share some of that as I look a little bit more about some of the functionality of some of these chips in the next part, and cover some of those prior repair logs kind of thing. You know, it might just help you out. Anyway, I do hope you found that interesting. If you do like the videos, please consider subscribing. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.